Hello and welcome to our mcube 5.2 update. My name is Andy Diggelmann. I am the Chief Product Officer at TCG Digital and will discuss the latest enhancements in our end-to-end AI platform with our expert panel. We have Ashutosh Ranjan, head of our global data science team, Sascha Losco, head of our semantic and ontology-based solution development, and Debjyoti Gupta, our Chief Technology Officer here at TCG Digital. As we are entering the era of AI agents and agentic applications, we will look at mcube 5.2 through agentic lenses. But what else do we have in store today? We will also hear Thomas Heinzerling, Senior Vice President at Linde, talk about the real-world impact of these technologies optimizing autonomous plant operations. We will also look at the demo showing our newest release, mcube 5.2 in action, and we'll end this discussion with a look at how agentic technologies improve the world of one of the most popular sports worldwide, football or soccer as some of us call it. Several months ago, I concluded our launch of mcube 5.2 with the summary that we opened the door to agentic AI. Today, it will become clear that not only a door, but the floodgates have opened for agentic applications with our newest release. Our investments in multimodal AI frameworks allow orchestration of very different types of agents. Investments in semantic technologies not only ease information access for end users, but also allow for agentic applications to leverage contextual information in real time. And finally, investments in cloud-native data integration technologies addressing the challenges of real-time data flows across multiple environments drive actions and answers agentic applications provide to end users. Let's discuss all of this in a bit more detail with our panel now. Ashutosh, what key enhancements does the new version of mcube bring, and how does it support agentic AI?
So we have focused on all 4 building blocks of agentic AI, and our enhancement revolve around these 4 building blocks. The first one is LLM itself, LLM or reasoning models. So as we all know that every day some or other new enhancement or new innovation in this field is happening. And so, for example, few days ago, Llama 4 got released by Meta. And this is again a new age multi-modal LLM and also capable of reasoning. So any agentic AI application needs a reasoning model as a backbone of it, which can help collaborate between multiple agents. So collaboration is the second building block, and how different agents can collaborate together, how they can coordinate and adapt together. That also is driven from which reasoning model are we using and how robust these agents individually are. And for that, the third building blocks come into picture, which is the context and contextual information. So for a big business where we are generally working, there are lots of information and different departments, and also the principle on which a particular organization work on. So all these information are generally kept as SOPs and different documents, right? And all those context related information comes to our TCG mcube as different ontologies and knowledge graph. So that enhances the impact of agentic application a lot more stronger. And the fourth one is the governance and compliance feature. So as we all know that agentic application are supposed to work in semi-autonomous or autonomous manner. And when we are giving the control to the machine, lots of guardrails and lots of compliance related things need to be put on. So in TCG mcube, the governance, data governance and AI governance comes out of the box, which again helps the user to configure their own agentic AI application and monitor it in real time.
Yeah, and trustworthy AI, I think, is a really, really important keyword in this context. So how do our agents collaborate within mcube to automate complex workflows?
Right. So in TCG mcube, AI agents generally specialize in different roles, and these are smaller agents which sometimes also are referred as tools. So there will be one agent to bring the data from different sources, like real-time data from IoT sensors, some financial data from RDBMS applications, right? And then there will be another agent or another tool which will be responsible for doing the EDA and creating the AI model. Another tool will be responsible for basically sending out the emails and alerts. And all these tools and agents need to collaborate with each other. And that's where we have our LLM integration framework, where the LLM, the master LLM or the supervisor model, we call it, they help coordinate between all these models. And the modular approach actually help us plug and play different agent for different system, and it also help with reusability. So for everything, we don't have to always create the agent. Lots of agent will come out of the box going forward. And unlike traditional automation, which follow like a rigid workflow, our agents in TCG MQ are context aware. They have the capability of reasoning using the knowledge graph and ontology. And with multi LLM support, plug and play, we can also ensure whether we want a most cost effective model or whether we want most secure model. When we talk about secure model, basically we host LLM inside our premise privately, and so that we are not sending any data and any context outside our organization. Yep.
So this is a very, very new way of collaborating, not amongst ourselves as a team, but actually our agents collaborate with each other. Fascinating. I think it's now time to have a look at the impact the new technologies have on how we are operating plants in process manufacturing, for example, to achieve higher EBIT and improved reliability. For this, Thomas Heinzerling, Senior Vice President, Advanced Operation Solutions at Linde, summarized this view for us.
When I talk to our customers, I consistently hear three key challenges at the moment. The price of raw materials and power, as well as demand and price for products, become more and more volatile. Just think about what is happening this week. The pressure to increase EBIT through productivity gains is rising, and it's becoming increasingly difficult to attract and retain qualified and experienced staff. What does that mean? If we want to maximize EBIT, we now continuously have to change the production mode of our assets according to fluctuating prices for raw materials, power, and products. The classical systems that we need for this are complex and constantly now need to be adapted to new operation scenarios and changes in the plant hardware by highly qualified humans. And as our customers struggle to provide these highly qualified humans, sufficient experienced staff to do this adaptation, the system performance deteriorates, and with it, the EBIT. The way out of this are self-optimizing plants. This means the plant understands the key KPIs to optimize and learns which levers to pull to optimize the KPIs through experience. At Linde, we believe that the future of industrial operation lies in this intelligent, self-sustaining, autonomous plant operations. Since we already have several years of experience with self-optimizing solutions that operate large process plants, we know that this is not a dream, but a reality today. Our collaboration with TCG Digital is intended to accelerate the deployment of this solution. The collaboration unites Linde's market-leading experience to deliver AI-powered, robust, closed-loop process control using our own operating experience at scale, and TCG Digital's leadership in AI-driven part intelligence. Our objective is to transform the operations of our customers towards autonomous operations with software solutions that learn how to self-optimize for highest yields and maximum efficiency for all the different operating conditions. At the same time, pervasively monitoring equipment health and process safety, boosting reliability and safety through AI-powered decision support. At the heart of this collaboration is Linde's AOps Ignite platform for automatic plant startup and production mode changes, as well as for AI-powered advanced process control. and TCG Digital's mcube platform for AI-based real-time analytics and real-time optimization. These platforms provide the basis for a fast deployment of robust large-scale solutions that continuously determine the optimal asset operation mode, automatically move the assets to this mode, and optimize steady-state operations. This partnership enables us to help our customers to swiftly maximize their EBIT with little risk and fast return, improve safety and sustainability, and cope with experienced operators becoming a scarce resource.
Improving EBIT, safety and sustainability with minimal risk. What a fascinating outlook. We are setting the bar really high for our partnership. Coming back to our mcube 5.2 release now, we added a whole new module for creation and management of knowledge graphs and ontologies. So Sascha, in the age of agentic AI, what is the role of knowledge graphs and ontologies and semantic modeling?
All right. Yeah, Ashutosh briefly touched upon that already. When we talk about agentic AI, the critical piece often missing is context. A system can only make good decisions if it understands how data points and concepts connect throughout the enterprise. That's exactly where knowledge graphs, ontologies, and semantic modeling come into play. If you look at knowledge graphs in more detail, then you can think of them as a network of linked information. Instead of having data in separate databases or spreadsheets, a knowledge graph ties all your key entities, for example, machines, processes, products together, and shows how they relate. For instance, in a manufacturing setup, you're not just storing a machine ID, you're also capturing which process step it belongs to, the materials it handles, and its maintenance schedule. This big picture view is much more powerful than isolated data. And ontologies actually then provide the rules and definitions behind those connections. They act as a kind of dictionary or guidebook explaining how different elements in the graph should be interpreted. In the pharmaceutical context, for example, patient has a specific implications about safety, trial phases, and dosage. So if an AI system detects an irregular reading from a sensor, the ontology makes it clear how serious that is in terms of, for example, regulatory limits or potential health risks, rather than just flagging it as an error. And actually, this context is crucial for an agentic AI. Picture an autonomous AI agent receiving a notification like sensor 101 is running hot. Without context, it can't judge how critical that is. With a knowledge graph and a well-defined ontology, the agent knows that sensor 101 belongs to a key subsystem where a breakdown could affect production or safety. Having that situational awareness helps the agent make the right call, perhaps slowing the process or altering a technician, alerting a technician for urgent maintenance. Another key factor is transparency. So traditional AI can feel like a black box, which is risky if you're in a regulated industry like finance or life sciences. With semantic modeling, you can trace how decisions are made because the AI is referencing clear definitions and rules in the ontology. That's essential for audits, compliance, and gaining trust from stakeholders. And also, as Ashutosh mentioned that already, many agentic applications involve multiple specialized AI agents, one for predicting supply issues, another for scheduling, another again for monitoring equipment. If they don't share a common language, they might make conflicting decisions. And a centralized semantic layer solves that by acting as a universal translator. All agents draw from the same knowledge graph, so they interpret data consistently. This is critical for real-time cross-functional coordination.
Yeah,
and finally,
we definitely don't want the agents to stumble over each other, do we? Right?
No, we don't. Maybe there's one last important part, and that's scalability and flexibility. As your business evolves, introducing new product lines, compliance rules, or data sources, you don't have to rebuild everything. You simply update the ontology to reflect the new definitions, and the knowledge graphics tend to incorporate fresh data. The AI agents automatically gain a more complete and updated view of your operations without needing to be reprogrammed from scratch. And I think that's, in a nutshell, knowledge graphs, ontologies, and semantic modeling provide the foundations that fuel agentic AI. And they turn all these scattered data resources into a well-structured, meaningful resource, helping AI systems make more accurate decisions with greater clarity. And that's the reason why we heavily invested in these semantic technologies for TCG mcube 5.2, because it's how we go from standard automation to truly intelligent, adaptive workflows that drive real business value.
Thank you for outlining the impact of semantic technologies and ontologies on how agents actually can behave and how agents can actually act on our behalf. Let's look a little bit more under the covers though. So what is the significance of semantic technologies and related ontologies for the foundation of a strong agentic AI strategy, which is the data lakehouse?
All right. Yeah, data lakehouse combines the huge storage and flexible ingestion of a data lake with the structured query capabilities of a data warehouse. This means that you can keep a lot of raw data in one place while still querying it efficiently. Now, that's useful if you just want to store and retrieve data. But as soon as we talk about agentic AI, we need to go beyond just storing things. We need a layer that helps AI interpret, govern, and apply this data in a context-aware way. That's exactly where our new module semantics within TCG mcube comes into play. Its ontology-driven approach serves as a single repository for semantic models, ontologies, control terminology, and metadata, making it easier for both systems and users to find and use relevant data. You can think of a data lakehouse as a library with massive amount of information. By itself, it doesn't really tell you what each book contains or how they relate to each other. Semantic models serve as the catalog system, describing what each data set means, how it should be used, and how it links to other data sets. An ontology is basically the blueprint that defines the concepts in your domain, like machine, maintenance schedule, or production goal, and the rules that connect them. And this is critical for agentic AI. An AI agent might be pulling data from sensors, enterprise apps, or external sources, and then deciding how to respond. Without a semantic layer, the AI just sees raw data. It can't tell whether sensor 101 is part of a key subsystem or just a secondary device. With ontologies, the AI knows exactly how these elements fit together and can make well-informed decisions. It can alert a human operator if something critical is failing, or even take preventative action by adjusting processes automatically. And you also get traceability in regulated industries, healthcare, finance, pharma. You want a clear record of which data was used and for what purpose. Semantic metadata can capture lineage and usage rules so that you know exactly who or what accessed certain data and why. And this is invaluable for compliance and building trust in autonomous decisions. You can say, yes, this AI recommended adjusting production because it analyzed these 3 data sources under these conditions, and it's all documented right there in the ontology. And we've talked about cross-functional collaboration already. Ashutosh made that point quite clear. In a plain data lake, each department might dump their data with different labels, creating a data swarm. Semantic models bring a common framework so everyone labels and references data consistently, and this makes it easier for new AI agents and actually for analytics teams as well to discover relevant information without having to translate a bunch of ambiguous field names. Essentially, it saves time and reduces confusion because all the data is described in the same shared language. And embedding ontology in your data lakehouse lays the foundation for adaptive and explainable agentic AI. These AI systems don't just retrieve data, they learn from the relationships defined in the ontology and can adapt when those definitions change. So this means you can add new products or new compliance rules, and you can simply update the ontology and your AI agents automatically operate with this new knowledge. And I think this is a future-proof approach because you're not hard coding every rule into the AI. You're letting the semantic layer handle that. And the AI can also show you the reasoning path it took, which is huge for trust and transparency, especially if you need to demonstrate how a particular decision was made. So yeah, summarizing all that, semantic modeling, knowledge graphs, and ontologies are what transform the data lakehouse from a massive storage space into a knowledge-driven platform for agentic AI. This extra layer of meaning and context makes a big difference in how effectively and responsibly your AI can handle real-world data and automate complex decisions.
Thank you very much, Sascha, for that concise summary. It's really nice to see that we're not only focused on technology, but we are focused on how that technology can be used, how it can be transparent, how it can be trusted, which we hear a lot about, questions about should I learn from something which I'm not quite sure if I can trust it. But we have seen that the semantic layer can lay the foundation for advanced agentic AI and analytic pipelines. It can enable sophisticated insights transparently and help dynamic decision making. Because semantics is part of mcube 5.2, it can be leveraged seamlessly by multi-agent orchestrations, further enhancing the platform's AI-driven automation capabilities. That is really, really important. Now, let's switch over to Ashutosh, because I'd like Ashutosh to share a few examples from your current portfolio of projects that you're working on, so we get a little bit of an idea what the data science team is doing with all this new technology that we're talking about today.
Right. So we are working on agentic AI to solve quite a few problem statements. So I will start with a simple supply chain problem where agentic AI model is coming together and it is retrieving the data, running some SQL query, and everything is natural language enabled. So you can just ask question and it is going to train an AI model. It is also going to send an alert or post an order on your behalf without going into and looking into data, and it will also show all the reasoning. So that is one such example. Another example that we are solving is in the field of catalyst discovery. So where we are accelerating and helping the scientists discover the catalyst faster by training fine-tuned LLM model on thousands of research papers, combining it with another agent which is specialized in design of experiment, creating lots of hypotheses, permutation combinations, and then combining ontology to filter out the information and the hypotheses which are not feasible. And the third one that I'm going to talk about is plant reliable AI. So where we are doing combining predictive maintenance, the classical predictive maintenance, I would say, ontologies, generative AI, and agentic framework, everything together to make the plants and industries more reliable when they are running the manufacturing units. And here on this slide, you can see that the data on the left hand side is coming from all different systems that you can think of. A structured data from sensors and process and LIMS systems, right? Then comes the semi-structured data, which are like system logs and trouble registers. And not only that, but also PNIDs, PFDs, SOPs, all the unstructured data and document. So utilizing all these data, we have trained the vector embeddings and semantic layer, both kind of agent. And also parallelly, we have created anomaly prediction models on structured data so that it can predict the anomaly before it actually occurs. And not only occurs, but it will predict in time so that you can take some mitigation step to stop the calamity or the interruption in the plant happens actually. And everything is orchestrated by the LLM master agent or reasoning agent, which I was explaining in the first part. So the query goes to the master agent coordinate between different other agents and finally give the answer and recommendation. So the one part is predicting the failure, second part is giving the recommendation on how to troubleshoot that failure, when in the past history this failure has happened, combining it with the cost data to see what it translates into in terms of cost if this interruption happens in the plant. So I'm going to switch to a short demo and show you a short demo on how the interface and the application works. Okay, so in this landing page, you can see a simple schematic of the plant on the left-hand side, and then we have a drop-down where you can select multiple different departments of the plant. And there are multiple components with individual anomaly prediction model being generated here. So between two part of the plant, HP and DP, we are going to look at HP right now, where we can see that in one of the component, there is some anomaly which is occurring. And this component 2S1411C, we are going to look at it. And what it will do automatically, it will generate the alert. And using that alert, we will be able to see whether in the past something similar has happened or not, like PTA water operation and CTA rate down 90%. So now we can see whether similar problem has occurred in the past or not, and everything is being served by different agents. And now on the screen you see that information which is coming from the historical data. So it combines all of them, like repairing time, downtime, financial loss, productivity loss, and also what was the repairing cost. So you can imagine that all the data like process data, operations data, and financial data are being combined together, and then you are getting this report. And then we go to the mitigation, where we see the licensor recommendation and OEM recommendation, based on which we can troubleshoot the plant and we can mitigate the risk well in time. So this is the demo that we were planning to show you.
Thank you, Ashutosh. I think it's now time to look at the part of the iceberg which we haven't covered yet, because it's usually hidden under the waterline. Debjyoti, I heard you say again and again, AI is only as good as the data it can leverage. Why is that so?
That's right, Andy. Actually, AI is actually inseparable from the data. And let me simply put it in 2 points. So dependency of AI models on data plays out on these 2 fronts. Number 1, the AI models need clean and accurate historical data, usually in substantial volumes to train, in order that these modules are effective to predict with accuracy and reliability. When we are talking of AI carrying out real-time predictions, and this is the second part that we are talking about, this is AI agents are carrying out real-time predictions to help in decision making. They need to be served event data in real time with the least amount of latency and with absolutely very high consistency. So think about an AI agent. It's designed to act autonomously, making decisions and taking actions with minimal human intervention. It probably focuses on a goal-oriented task like keeping a production process tuned to the maximum efficiency. The recommendation prescriptive actions that this agent is supposed to provide would be continuously adapting to the changing environment. So the data integration, the pipeline kicks in here. It provides the right data at the right time to this AI agent to then make the prediction.
All right, so taking it from there, what are the highlights regarding data integration functionality in MCube 5.2?
So here is an infographic which describes the data management capabilities of MCube 5.2. So firstly, it is a no-code data engineering, which is actually very highly contributing to the productivity. Then this data management engine is actually a multi-engine pipeline. So you can have row-based processing, you have cluster computing using bulk data, in-memory computing. So you can adapt to the demands of the workloads of the processing which is required in order to frame the pipelines. The entire end-to-end pipeline management is automated and it is scalable. So it can very seamlessly scale depending on the workloads. The pipeline has cloud native architecture, so that means it is deployable on any cloud and it can connect to data sources, whether in the cloud or on premise, and very seamlessly process the data and bring it over to, as you can see on your right side, there is the lake house, the data marts where the data are being fed. The pipeline management among many data engineering users, it can be collaborative and people can work on building these pipelines together. So that is another productivity enhancement that this tool brings along. And finally, we are talking about the real-time capabilities. And as I already mentioned, for real-time agentic AI to work, you need real-time data to be fed into them. So that's why if you look at what this data management tool does is it brings data into your lakehouse, it brings data into your marts, it can connect with the semantic layer and add to the context. And this has been spoken about by the speakers who came before me. And finally, the real-time data pipeline feeds can go directly to the AI agents. And to wrap up the whole thing, this entire operation and the functionality is very neatly encapsulated, offering the premises of data quality, providing the security and access to the data, having a full end-to-end governance process built in, and obviously the connectivity to the semantics. That in short would wrap up the data management capabilities of mcube 5.2 Andy.
So if we look at this from an enterprise class AI deployment at scale point of view, if we try to put on that lens in front of our eyes and look at how we are moving forward, how do those integration capabilities uniquely position mcube 5.2?
Well, I would say I would point out one illustration here, and here I'm going to illustrate why this is unique. So what our data management capabilities do is it is actually tying up two things, the semantics and the AI. So in fact, it's a trifecta of the data management, the semantic layer, and the AI, which makes this proposition very unique. And this is another infographic which is trying to illustrate the case that I'm talking about. So the real life world is represented, by a certain behavior, the process behavior, which actually is typical under different scenarios, or let's say the working envelopes. This behavior of the processes is actually what is contextualized and stored in the semantic layer. Now, when a real-time feed comes in, and it is received by, let's say, the first agent, which we shall call a decision agent, and this agent's job is to decipher this real-time feed in the context of what kind of a performance envelope is this feed coming out of. And depending on this, it can then take the decision to route it to the right optimizer agent. And here we are talking about, there are three different agents, as you can see at the next layer, and which actually are running different models which pertain to the different operating conditions. So routing this data to the right optimizer model is what results in the correct decision or recommendation to be done. So that's what the little flow here of an autonomous AI agentic workflow ends with the actual instructions or the feed going out to the outcome processor, which can be, let's say, a warning message, or it can be a feed to an APC, that's an automatic process controller, to actually correct the process. But whatever it is, in the situation that in a real time there is an autopilot which is continuously monitoring where the process is headed and where it should go, this interaction between the contextual semantic layer and the real-time feeds and the decision-making capabilities of the AI agent is what makes this entire process absolutely effective.
Thank you, DG. Very enlightening and a lot of information we have seen so far. So let's now switch the context a little bit to what Pelé called the most beautiful thing in the world. It's called football or soccer. The following video shares how the German Football Association, DFB, is leveraging mcube and Agentic AI as they move football and the related entertainment industry and the related execution for their teams into the future. Let's have a look.
Football is getting smarter, more inclusive, and more exciting than ever.
So now excitement is very high.
DFB, the German Football Association, the very heartbeat of German football, has joined forces with TCG Digital, a global leader in data and advanced intelligence, to redefine how fans, players, and stakeholders experience the game. Together, they are setting a platform for a new era of footballing innovation, ensuring that the world's most loved sport remains a global phenomenon uniting billion passions. At the heart of this cooperation is a groundbreaking co-innovation lab that seamlessly integrates sports intelligence into football. From enhancing fan engagement to scouting the next big talent, this initiative is transforming the sport, starting in India and expanding worldwide. Let's take a look at 5 revolutionary instances that are changing the game. Imagine watching your favorite football match with live commentary in your own language.
With a monster touch, I would say. एक जबरदस्त touch है, मैं कहूँगा.
Thanks to TCG Digital, fans across different regions can now enjoy live matches with commentary in multiple languages, making the experience more immersive than ever before. No matter where you are, TCG Digital and DFB ensure that you never miss a beat. Accessibility is at the core of this innovation. With data intelligence generated subtitles, football fans who are hearing impaired, or prefer reading along, can stay fully engaged with real-time updates and analysis, enhancing the overall viewing experience. Football is now more inclusive than ever. For those who missed the live action, comprehensive match reports will be generated in 11 regional languages, just moments after the final whistle. This sports intelligence, powered by TCG Digital, ensures that football lovers get detailed insights in their preferred language instantly. Time is precious, and fans want instant replays. With sports intelligence-driven content generation, match highlights will be seamlessly curated and available immediately after the match ends.
Cross goes deep. Oh, it's a good chance!
Every thrilling goal, every game-changing save, all delivered straight to your screens at lightning speed. In today's digital world, social media is where fans connect. TCG Digital's advanced intelligence platform will automatically generate 30-second highlight reels, curated during live matches, and instantly share them across platforms like YouTube, Facebook, Instagram, and more. Football has never been more accessible, shareable, and engaging.
At TCG Digital, we always try to push the frontiers of what AI can do. We work with very large enterprises around the world, and DFB is the largest football association, maybe the largest sports association?
As a German Federation Football Association, it's our aim, it's our goal. We strive to make football better, creating products with the help of AI, showcasing products, making it available globally, localizing it, making it available in the local language.
India is such a big and important country that it's very important also to bring the sports football high and to develop it, and it's maybe a small step in the right direction, but we are really eager to start.
The world is so big. Everything that matters is like a great collaboration, a great partnership between at least two institutions to make something successful and to scale something across a market. And I mean, if you're just looking at the Indian market, it's huge. So looking at TCG Digital as well as the Indian market and DFB in collaboration, that's quite an interesting collaboration, and I'm really excited.
Beyond enhancing fan engagement, TCG Digital will deploy the power of mcube, their advanced data and AI platform, to scout young talent from grassroots levels, tracking performance in youth matches and training sessions. This initiative aims to propel India onto the global football stage, revolutionizing how talent is identified and nurtured. The future of football is here, smarter, faster, and more connected than ever before. With TCG Digital and DFB leading the way, fans can expect unparalleled experiences, players can be discovered like never before, and the beautiful game will continue to unite hearts across the world.
I think that was amazing and exciting to see how Agentic AI and mcube 5.2 play a crucial role in improving business processes across the globe and across industries as diverse as process manufacturing and sports entertainment. As companies reap the benefits of digitalization, we are proud to accelerate their velocity to value. I hope there were a few inspiring nuggets in this event for every one of you, and I'd like to thank you for joining us. Please feel free to contact us if you have any questions or thoughts you would like to discuss. We and all of our agents are looking forward to collaborate with you. Thank you for your attention and participation.